If we take a step back, most volcanoes actually occur on the boundaries of tectonic plates. Hawaii is a little bit different. It occurs in the middle of the world's largest plate, that's the Pacific. Now, the big picture that we have today of the Earth is that it's undergoing something called convection. That means hot material is rising and cold material is sinking. Beneath Hawaii is an area where that hot material is rising. It remains relatively fixed. As the plate moves above it, it causes a volcanic chain to emerge at the surface as it begins to melt. Now, the mystery is that around 3 million years ago, that volcanic track split into two parallel tracks, and no one really knows why. So you should see the green plate moving above what's called a mantle plume, the hot, buoyant mass of rock, and it's got two distinct magma regions which are feeding two volcanoes at the surface. As the plate rotates, you'll see that the two tracks begin to diverge. So it's really that plate rotation that's causing the divergence of the two volcanic tracks. The fact that we can relate these features to shifts in the tectonic plates means that we can go back in time, look at where they exist elsewhere, and then infer that there must have been a change in the plate motion then. Then we can reconstruct the Earth's tectonic plate history. We can figure out how the past got to the present and what the Earth might look like in the future.
And does this also account for why these Hawaiian volcanoes are so big and so active?
Yeah, so the reason they're so big and so active is because the buoyant mass beneath them is so large. They're at very high temperatures and there's an extremely large volume of rock. As that rises to the surface, it reaches low enough pressures that it can begin to melt, and that melt is transported to the surface as magma.
And is this how the whole of Hawaii was formed, Tim, from this shift of tectonic plates 3 million years ago?
Yeah, that shift at 3 million years is essentially what caused the two island chains to emerge. I actually have a little prop here that helps you understand it. Your viewers could do this at home if they want to. All it is you need two pens of different colour and a piece of paper. If you draw a straight line down a page, you can see you get a single line. If you change direction, you can get two tracks. That's essentially what's happening at Hawaii, except instead of two pens, it's two magma chambers feeding the volcanoes.
So can this be used to predict future eruptions, either in Hawaii or elsewhere?
The better we understand what's beneath Hawaii, the mantle plumes, the better we're going to understand what's going to happen in the future. Essentially, these double tracks are occurring all over the globe, and we believe this process is at least responsible for the double tracks that are occurring on the Pacific plate.